All right, let's go ahead and get started. Welcome, everybody. My name is Dan Loftus. For those that you don't know me, I'm Director of Sales for HM Cragg's distribution business. Appreciate you all taking the time to join us this afternoon. Hope all of you and your families are safe, so welcome. I'm pleased this afternoon to host Mike Hadt. He's from RLE Technologies. RLE's one of our newest partners that we're working with, and we've been working with them for about 6 months now on primarily environmental monitoring, and we found their wireless technology to be really interesting, and we've had some good applications for that. So we've installed their product in our facility and have a pretty cool demo set up, so we're going to talk a little bit about that today. Today's goal is really to give you a high-level view of some of the products that match up with what we do with many of you. So I think you'll find that it blends into some of the products that you're currently buying from HM Cragg. You'll be muted for the presentation, but we'll unmute at the end for a Q&A. But I also invite you to use the chat function. There's a way that you can send in a question via the chat box down below at the bottom there. So with that, Mike, I'm going to turn it over to you.
All right. Well, thanks, Dan. Thank you, everybody who is dialed in. I certainly appreciate the opportunity to share in some opportunities to solve some different problems. We're grateful for HM Cragg's partnership and certainly looking forward to all the great things we get to do here in the future. But as Dan had said, we certainly do have some great technology that fits a variety of different environments that really solves problems. And ultimately, that's, I think, the opportunity that we're looking to present to the team today. So RLE as a whole is really geared around 4 product lines. The Falcon, which is our environmental condition and critical equipment monitoring system. Different than maybe some of the UPS Falcon that you're familiar with, but hey, what a great way to marry the two together and bring some of the information back for us to help to monitor in that enterprise system. The Seahawk is more of a water damage protection, infrastructure protection. Critical spaces obviously can't have water, so we got a couple different systems we'll review there. The Raptor line is a integration Enunciation platform that integrates well with other systems as well. And our Triad line is really our performance airflow products, which is a complete raised floor systems, as well as the hot and cold aisle containment that is geared to reduce, actually improve the airflow, in many cases reduce the airflow and increase temperatures in some zones to save some energy and money ultimately. So the few product lines is kind of the way I'll step through the presentation. As Dan had said, there's some different products that they have available for demo as well that we can all chat about later as well. So to get started with the Falcon line, it's more of our enterprise facility monitoring system. Kind of drew this up the other day just to kind of show how we all integrate environmental conditions monitoring back to could be our FMS. The systems that we have do talk different protocols that are accepted amongst all the players in the controls business, which is BACnet, Modbus, as well as SNMP. Not all of them talk all of that, but many of them do. So really what we're showing here is our way that we can impact environmental conditions from a protection point, an environmental monitoring, critical asset standpoint, as well as how some of the products can integrate with other products as well. So in this diagram, what we're showing is our FMS facility enterprise system on the top end. This is our enterprise enunciation system connected to our F200, which actually is connected with a camera to trigger a recording function. We have our ability to monitor any environmental condition effectively with our wireless system, which is a 900 megahertz, as well as a Wi-Fi temp humidity that can sit on any Wi-Fi network. And then our power fail monitor and leak detection systems as well, all integrate back to a system. And in many cases, what we're looking for is which part of these systems in many cases currently don't exist in a customer location. And what's really the opportunity, and I think that's ultimately what we wanted to kind of get down into and through, because ultimately a lot of our customers are enterprise users, right? They have sites across the country and inside of a campus environment, things along those natures. So our enterprise system does have some delta view capabilities to grow from a pictorial format, the alarm enunciation and signal enunciation for easy viewing for different securities to help to manage. And then getting into our FMS as well, what we're looking at on the loaded up scale is quite a lot of inputs and outputs that would be available to monitor through the system. So we can be a little flexible in the way that we add an A card, which is more of the analog inputs and outputs, as well as a C card, which is more of the digital inputs. But up to 104 inputs can reside inside of one of these enterprise systems, and that's physical inputs, right? So in short of obviously reading all of this, I'm not going to go through all of it, but a few of the key points here are the full accessibility with integration capabilities with the SNMP, Modbus, and BACnet, the email notifications that are going to get sent out, as well as some of the delta view and nesting graphical enunciations that we're able to display with this as well. Simplicity, I think, is key with all of this, and ultimately, when you're getting to it, that's how hard is it to install, to maintain, to support long term. Those are all things that the end user, as well as you as a contracting group, is really looking after. So, but just as important, what else can we connect to it in a future state, right? So any hardwired input from effectively any sensor can come into it, as well as any integrated point that you may be pulling from some other system to be monitored in the FMS, okay? There is some alarm enunciation that's capable, obviously, if you have access to a VPN or viewable rights to log into a system, you would be able to view some of these alarms remotely from your phone, or you can also receive the email alarms or even text alarms that traditionally can come out of those systems. And from our facility monitoring system as well, I mean, taking it, if you remember, the FMS was on the top level. The F200 is a critical space monitoring device that really is geared towards littler environments, right? It could be a data closet, it could be an IDF closet. You may have just one temperature probe, or 2 or 3 or up to 4. But you can also have spot detection in some of those spaces. You can integrate a camera link into those. The relay output status, as well as different event notifications, are all monitored here with a simple setup user interface, and 8 digital inputs as well. So those inputs could be motion sensors, door contacts. We have a power fail monitor that would trip an alarm should a power fail to an environment, or even like a motion sensor. It could be even like a hydrogen sensor you may have in some battery rooms, So as part of the FMS platform as well, we're getting into now more of the wing wireless technology that Dan had made mention of, and really going to review some of how this can be applied, and really the different environments that you could get environmental conditions out of now very simply using a wireless technology. So the wing manager, as you saw up here, can be rack mounted, comes with a couple of antennas, and then also has the ability to pull in any one of these temperature conditions, temperature and humidity. We're doing some nice projects now with wireless leak detection in some different buildings, just because of the simplicity of deployment and the high value you're able to receive from that. Any digital input, so there's some different relay alarms that may trip a closure, a door contact, things of that nature are all wireless capabilities now. But what I think is neat is inside of the industry is our ability to connect effectively any analog output from a sensor. Could be a 4 to 20 milliamp output, a 0 to 5 volt, or a 0 to 10 volt output, and transmit that output wirelessly back to the gateway in order to deliver environmental conditions monitoring, or again, an integrated point back to some other system that could be deployed for optimization or a sequence of operations to improve control logic. So again, think a little more about the environment that you're in and what all can you be looking to connect. There's another project that I'm just now working on using our wireless RTD probe for freezer monitoring inside of a couple different environments where obviously freezers are going to get down to 0 to -20, I believe is where they're at. And we have that ability to go ahead and bring all of that into a single monitoring station. But you can also use that for differential air pressure as well. How important today is differential air pressure inside a building? Simple to deploy, and one of the creative ways to really think about it is it could be an on-site demo, or technically with a system that Dan has made mention of that they have available. It could be used on demand for potentially even a commissioning unit. How many times do you walk into a building and you're just not sure? You certainly don't always want to connect into somebody else's control system to change any logic, and you need some information to validate that what's going on there really is a problem. The Wing Wireless could be a great way to do that. Included with the wireless package, we have deployed now a Wi-Fi temp humidity transmitter that can sit on any Wi-Fi network. The 2.4 gigahertz Wi-Fi transmitter monitors both temperature and humidity, calculated dew point in the Wing Manager, and can be integrated in again through Wi-Fi back to the Wing Manager, and then integrated should those points be needed for some other system for a monitoring purpose or a control purpose, or any kind of analytics that may be being performed. They'd be able to be output BACnet, Modbus, or SNMP out of the gateway. Lots of folks, obviously, inside of wireless ask the questions around what's the protocol. It's a 900 megahertz protocol, which is nice because it has some great range, great capabilities as far as repeating. So our range extenders have about a 10x signal strength compared to our standard transmitters. And the architecture is a Wing transmitter to a Wing Manager or a range extender. Those typically will talk up to about 600 feet line of sight. General kind of rule of thumb in between buildings and things of that nature probably fall into that 200-foot range, 150 to 200 foot through a couple of 3 walls. And that's pretty good range. But now if you think about taking a range extender to another side of the building and getting that other 200 feet or 300 feet over there, now you can transmit that data back to the Wing Manager to up to over 1,000 feet away. So that would be kind of a simplified system architecture. And I was asked one time, well, what does 1,000 feet look like? So I ended up I live on the right, and I put the range extender in my kitchen, and I knew the guy on the left there and plugged it into his garage, and was transmitting data almost 1,200 feet away reliably for the 20 minutes I chatted him up and watched it. So the range extender certainly does have the capabilities to send a signal through quite a bit of information. So from here, I was going to kind of transition over to a couple of the products that we have just talked about, kind of more into a kind of a live demonstration type procedure. If you guys hang in there with me for just a moment. But while I prep that, let me kind of talk a little bit about the opportunity real fast. Being a reseller into the business, and my experience of being in building automation distribution for almost 9 years prior to coming into RLE, my mindset and my understanding of sales is obviously similar to yours, except what we have now today is an opportunity to grow sales through increasing the number of building problems you have the ability to solve for your customer. What's nice is that it's more of a low risk, high value sale. And then the other neat part is that it could be enterprise connectivity, but it also could be standalone. When you start to look at some of the other improvements that you're helping a customer to make, you're getting into the improved airflow performance and really delivering an immediate return on investment. So having had to walk through those calls and working with a number of partners and obviously purchasing groups, what I kind of learned to understand was how many problems did I think we can solve for $5,000 or less, and why is that number important? The number is important is because one, it's a highly probable sale because we're solving a problem that's affordable and often below the budget limit that gets approved almost always. So, that's kind of what we're looking at. And if, we start breaking it down, doing some simple monkey math, if we had an average product opportunity per zone that we can help to solve at $2,500, and let's just say you can solve 2 of those problems in 10 buildings, it's, minimally you're looking at a $50,000+ opportunity to grow your business. With simple problems that you're probably walking past, I don't want to say daily, but you probably have walked past through quite a few of these. But really, in my opinion, what I've also learned is what's important about it is you're creating a reason to solve a problem for them to call you back to solve a bigger problem for them another day. And I think in sales, that's genuinely important. So, when you start to get into it, you think about your service base and the customers, and after we go through a few more of the products, you'll start thinking, man, I probably could solve 2 or 3 problems in 10 or 20 buildings pretty quickly, and you can see how fast the numbers add up. So, I was working with another contractor the other day, and we just kind of roughed out some numbers and said, hey, if we can, if we estimated a single sensor would cost $300, and that's kind of just a rough general number, right? If we roll with that number in the math, and there's 350 sensors on a typical project, 150 do physically have to be hardwired. If you looked at the other 200 being wireless, there's no reason why you couldn't do it. And the opportunity then would be to reduce your overall cost, minimize any disruption and downtime, and potentially even improve your profit margins. So not all the jobs are going to be a very large job, but one leads to the next, which adds to the next, and ultimately you have an enterprise of opportunities ahead of you. So thanks for letting me spiel off on that a little bit. But I think that's ultimately the deliverable that we're looking at today, collectively as a team and as a whole. So let's go here. So we talked a little bit about the F200. This is a simple deployment device that is low dollar but high value. But if you think about the application, watch this video here. What I've done is kind of put together 3 minutes of what the F200 is all about, how it works, what it does. And I'm going to play this little video. There's some music behind it. I'll try to get you in on it, but if you don't hear it, it's available, and I'll make sure you guys have a link to watch it. So here we go. So again, this is for an IDF closet, right? We kind of package this up. And the F200, if you remember, has the ability to provide temperature humidity monitoring, leak detection, as well as 8 dry contacts, and has a relay closure for signal enunciation. So the F200, after you go through the following setup process, ultimately you get a user interface that looks something like this. All right, so I like sharing the video because a lot of people like to think that programming, setup, management of technology is difficult. RLE had a belief in the engineering and how they developed the technology that it has to be a user has to understand how to use it, and they built a lot of these just simple user interfaces that are easy to follow but elegantly work to really make it a neat experience to set up and certainly not a challenging one. So I hope that the F200, as you can see, was maybe a nice little video to share with you. And then as Dan had talked a little bit more about it, our Wing Manager and our wireless platform really is a system that you should look at. We have our demo site here, but I know Dan has some links to their site. But what I wanted to get in here was just to show you some of what we're using our Wing Manager for in our office, and obviously we got all kinds of sensors set up and all that. So it'll be fun to show you this. So again, the neat things about Wing Wireless is that it's simple to deploy. You pull a tab and it auto discovers in here. The battery life is up to 12 years on a single transmitter. The range is up to 600 feet line of sight from a transmitter to a manager or a range extender. General on average about 150 to 200 feet. But this is the neat part here that I think most people often overlook is how often is this transmitter talking? Our transmitters talk generally somewhere between 10 and 20 seconds per transmission. If you're a little further out of that, you may get a 30-second transmission. Sometimes adjusting some of the antennas would improve that. But certainly I think knowing that wireless that's ultimately real time, about as real time as it gets, is what we're ultimately delivering. So in this particular solution, we have set up our navigation tree, which is showing all of our systems, or our sensors, I should say. When deploying wireless, the biggest thing I think that is often a challenge is how good is my wireless network. So we built in these response signals into the user interface, so we know at any time how good of a signal our transmitters are communicating. If we have systems that may, and this is the other general rule of thumb with this radio frequency, you want to get as close to 30 is a good signal. So when you start weaning out to 80 or 90, you want to figure out how to either move the transmitter antennas or potentially consider a range extender in some environments. Our alarm console, obviously we got a common alarm in Ryan's office we need to set up and clear out. We have the simplicity of the user interface, again, naming it, setting your IP address, assigning relay outputs, The communications is slick because, again, we're getting into Modbus, BACnet. Here's your DNS. For any email that you may be sending out, you need the email, DNS, and SMTP information. And then as an admin, you also have some global settings where you would want to turn off your auto discover. You can click a button to start trending your data every 5 to 10 minutes. Your battery can be displayed in run hours or voltage. And anywhere that may be in a metric environment, simply clicking a button turns all of the values into something else. And then the other neat thing that I like to also showcase in the Wing Manager is the low battery alarm. So should you fall out of range or the batteries start to decline, let's say at year 8 or 9, you can set up a basic alarm to let you know that service needs to be done. A lot of the other products certainly have to have batteries changed a lot more often, which is obviously a cost and oftentimes cumbersome, especially in a heavy, dense deployment. So having an up to 12-year battery life is, we believe, pretty effective. And let's see if you needed to change any of the sensors. I'm just going to go in and click one of these sensors here just so that you, again, from a user setup standpoint, I think some of the challenge with technology is people think it's scary. In 3 minutes or less, you just saw me basically setting up an F200 device. In literally 5 minutes or less, you can probably get a pretty good start on setting up a Wing Manager as well. So when you set the readings, you have a trend level here that's being recorded. You can download that as a CSV. You can view the log archive as well. Each sensor also is showing its own individual wireless network metrics. Any activity history that may have been bothered by that particular sensor. And then sensor configuration, simply call in how you want to name it, sensor name, give it a location. And then this is another neat feature that on some of the sensors you may want to play with, which is an offline alarm delay, meaning if the sensor does not communicate back to the Wing Manager or a range extender after 2 minutes, you would get an alarm. Obviously, that would be important to know that the sensor got knocked off or it's not communicating. You want to know generally within 2 to 5 minutes, which is a capability that we certainly have that on. So the other nice simple thing that you can do is set up the alarm notifications. Again, just intuitive user interface, setting up whatever conditions you want on a high temp, low temp. Have the ability to move that sensor. Let's say it was the 50th one in the box that you pulled, but you really wanted in position 2. You'd simply be able to pop that in there and move it on the user interface. You hit save changes, and anything that you would have changed would be saved. And then from an integrator perspective, again, this is, I think, one of the biggest things that most of the integrators appreciate the most is the fact that we put all of our sensor objects for each integration capability on each individual sensor in the Wing Manager. So there won't be any late night Google searches trying to find what anything is. It's all right here in front of your face. That simplifies deployment as well as integration. And Dan has one of these and likes to demo it. So if you have any applications or would like to inquire about some in-house demo equipment, let Dan know, and certainly we can accommodate figuring that out for you for whatever it is you may want to take out and play with. Let's see. So so that's the wireless side of the technology. I'm going to just show this to you real fast as well, since I have a captive audience, which is our facility enterprise. Remember I showed you that network diagram. This would be the top end of it that would have that capability to pull all of the different devices into a single user interface for the purpose of monitoring or even integration. All right. So here's, again, this is broken down. So we have a couple different systems brought into this. And I think one of the nicest things I like to show on really logging into the FMS is the simplicity of just how it's laid out. And if it's good or if it's in an alarm, it's red. You can integrate some different data points and how you want to see the data. We have a couple different products that we actually linked up down here. So our F200, our Wing Manager, we have a couple different leak detection systems that are all integrated back to this FMS for the enterprise view of visibility. So if I click this would be the next section that I get into, which is the leak detection. So let me go back to this presentation. And before I get too deep into that, let me touch on a couple things here. I guess I can ask if there's any questions before I keep going. But Dan, did anybody type in a chat request or anything?
Nope, no chat requests.
All right. Well, we'll keep moving. So the other thing about RLE, so the few things we talked about we were going to cover, right? We talked about environment monitoring. We talked about leak detection. We're talking about Triad, and we're talking about signal enunciation with Raptor. So our Seahawk platform is really identifying the obvious. The inevitable is going to happen. A fluid leak is going to occur. Fluid is going to create damage, and we have the ability to help to detect that. So leak detection comes in a variety of flavors. We have what's called a distance read leak controller, which would identify the location at which a fluid was comes in contact with a sensing cable or a spot detector. With that comes some alarm notifications. Obviously, this would be a user interface picture. But if you notice in the red up there, the distance read leak is stating that a leak was detected at 352 feet in zone 12 in the southeast corner of the building. So when you go through and do a commissioning of the site, you record all of these data metrics, which then allows the system to notify you precisely where a leak has occurred. So here's kind of a neat little data center design for kind of a large area that we took one of our larger 5200 systems, which can handle up to 10,000 feet of sensing cable. And then we deployed a couple, maybe 1,000 feet, where we got almost 2,000 feet of sensing cable. And the thing that is really the biggest way that allows us to do that is if you look right here in the middle, there's a little thing called an X connector. And its architectural design allows it to be a splitter. So you can come in with one and go out with 3 different directions, and you can split that 2, 3, 5 times, however many needed, as long as you're within the range of sensing cable requirements. Each time you use one, though, there is a simulated 50 feet of resistance so that we can identify that physically it went to another zone and there's not any crossover for how that all looks. But inside of leak detection, there's that higher level, more precise level of detection. And then there's more of a kind of a common zone level of detection where we're really looking at where did a leak occur in a particular zone. And then, of course, you got to have some different features, accessories, things like that to plug into. Our Raptor line is simply that. It's an integration platform that's geared towards enunciating signals. So we have relay replicators that can be 10 signals in, 20 signals out, maybe larger if really needed, but there's some smaller options as well. There's 6 zones of leak detection and enunciation, 6-zone enunciation. There's what we call a power fail monitor, which is kind of right on the bottom there in the middle. The PFM, it's geared towards enunciating an output, power output has been lost. So you plug it into your outlet, and when it loses power, it trips the relay closed, and then this power fail monitor would be an easy, simple add to an F200 in a closet, would be an add to another controller that would accept the relay output. The guy in the middle there is the protocol converter. This is a signal enunciation that is going to take, I know you're all in all kinds of mechanical rooms and you have equipment that talks Modbus, and sometimes you're trying to get it into SNMP. We have a protocol converter that would take that signal, bring it in Modbus, push it out SNMP, or maybe you bring it in BACnet and need to push it out SNMP or Modbus or one of those combinations. So there's certainly that. And then last year we actually launched a BMS line for one wire monitoring, 6 one-wire probes. We have a 3-zone leak detection, and even a mini version of the Wing Wireless that we demoed moments ago that would connect only 50 sensors versus the Wing Manager, as I showed you, would have the ability to connect up to 400. So it's more of a zonal type control that is looking to connect via BACnet MSTP or Modbus RTU. So that's really our Raptor line there. And then getting into really the meat and potatoes of what a data center is all about is airflow performance. At the end of the day, we want to guide that. We want to deliver the best airflow possible for the environment that's there. But oftentimes we're looked as retrofit panels, which is obviously a great fit, but we do have the ability to provide the entire floor structure as well. I do like to make sure to share that in any of those plan and spec opportunities, or even just maybe it's a 20-foot by 20-foot section they wanted to add on, or who knows. We have that ability to provide all of those as well. The performance airflow panels really is just that. They're built with a directional fin on the bottom to direct airflow. I'll show you in a moment. But the key advantages to this is the weight ratings, the airflow deliverable, which has been CFD tested, and the availability, USA made here in America. The difference between the slotted and the chamfer's on the right with a little cooler design. And then there's also the traditional aluminum grate that some folks just don't care, and that's all they need. So we do and can provide that. Here's a couple of other specialty panels between just solid panels. The Clearview panel on the bottom left is something that seems to be extremely popular, right? I mean, there's some folks that want to do cool things where they want to put blue LED lights underneath it with a nice glow that's tripped basically by a door contact that turns on. Some others have used Clearview panel for power or valves that's right underneath the floor, so that you have Clearview access. Others I've even seen use red lights to create some kind of a directional flow to an emergency exit. So certainly the Clearview panel is a fun one to look at, and the hybrid panel, obviously, for any environments where you kind of got a half a cabinet, but you still need some airflow, could be a good fit for that. So we got into, obviously, the data center business a long time ago, and one of the case studies that came around for specifically the floors, the triad floors we had just talked about, was the total number of tiles that were needed, the total amount of airflow, and the supply temperature being 55 degrees was the existing environment. You can obviously read all of these points here, but the total cost would have been over $3.5 million a year to basically run this situation. So we came in and actually helped deliver an a decreased number of performance panels that were required compared to the perforated tiles. Because of that, was able to reduce overall CFM, but was also able to increase the supply air temperature to 65 degrees versus the 55 degrees, which made an impact of roughly $350,000 a year in this particular site. So our airflow panels are, again, I showed the screen earlier of the opportunity, right? We've all walked through data centers. We've probably seen some old panels down there and some things that you just probably knew could be better, but hadn't really, just kind of walked over it. Well, again, think about the opportunity, the $2,500. I mean, it's likely an option that would get approved. It's solving a simple problem. Even if it was 3 to 5 to 6 panels that they may need, you're going to fall within that budget. With some of the environment monitoring, certainly you can fall within that budget as well. And I guess I'd like to reiterate that only because if you look around, I mean, all those little things add up, but also create a reason to get sticky with that end user as well, because you're noticed as somebody who helps them solve problems. So some of the CFD testing that we've delivered with our containment and our airflow really does come down to the 4% energy savings. It's a pretty good number to use. And obviously, airflow is one of the biggest things that's, I mean, you spend millions of dollars on air conditioning, right? And the utilities to operate it. If you only had that one last piece, which is the last thing that air touches before entering the space, the proper floor tile, we'd certainly love to help work with that. And then, you know, getting into that data center, we're really in a containment mode as well. That CFD modeling isn't just for the floors, it's for the containment. We want to capture that airflow and bring that down to a point that's manageable and is flexible though too. So RLE launched this in January, a containment line that is extremely modular. It's simple design, it's durable, but it's flexible. It's really a custom fit for your specific data center. And the doors that you're looking for could be like a saloon style, they could be slide open. You know, there's just a lot of different options that we look forward to providing some guidance on with any direction you have as far as cabinet heights and some of the information that we would require and to go ahead and move forward with. So I did have a couple of pictures just to show some of the sample projects that we've done. Again, with the different door styles, the colors between white versus black, the ability to go through obstructions as well as cabling, cable trays and things like that. We certainly can build around all of that, and would look forward to having that opportunity with you. So look up, look down, look around. I think there's opportunities everywhere, and we certainly hate to miss those opportunities to work with you and solve a problem with. So I guess in short, thank you, HM Cragg, and everybody that has attended. We're certainly grateful for all that you do, and stay safe, and anything we can do to help, let your HM Cragg associate know, and we'll certainly jump on it.
Awesome. Thank you, Mike. You've given us a lot to chew on there. So hopefully you've heard some things that that will maybe have you pause and think about just some additional ways that you can help solve problems for the end users that you're visiting. I know whenever we go out to see end users, they have some purpose in mind for us to be there, and we're there to help solve that problem. But as we walk through their facilities, we can certainly help them identify other ways to either solve problems or save money in ways that maybe they hadn't thought of.